Question number 8. F of x is equal to modulus of x divided by x if x does not equal to 0 or 0 if x equal to 0. We have to find a point of discontinuity. So we'll check at x equal to 0. So the given function is f of x is equal to, this is question number 8. In question number 8, f of x, the given function f of x is equal to modulus of x divided by if x does not equal to 0, 0 if x equal to 0. So at x equal to 0, so let's have f of 0. So f of 0, at f of 0 fx will be 0, so it will be f of 0 will be here 0. So left hand limit x tends to 0 minus f of x is equal to limit x tends to 0 minus f of x limit. The function of limit when x equal to 0, x less than 0, that is, it will give the minus of x. So it will give, first let's f of x divided by x, this is the function. So it will be limit x tends to 0 minus f of x. This is, it will be, since it is a left from limit, because this is the limit function, when it's equal less than 0 it will give minus, and when it's greater than 0 it will give plus. So it will be minus x divided by x. X and x eliminate, so the remaining will be 1. Limit x tends to 0 minus 1, that is minus 1. Right hand limit x tends to 0 plus f of x is equal to limit x tends to 0 plus f of x limit modulus of x divided by x is equal to limit x tends to 0 plus here since after this greater than 0, so this side it's plus, so x divided by x. X is x eliminate, limit x tends to 0 plus 1, so it will give 1. Left hand limit is not equal to right hand limit. Limit x tends to 0 minus f of x does not equal to limit x tends to 0 plus f of x. So it is discontinuous. It is discontinuous. The point of discontinuity is at x equal to 0. It is discontinuous. Continuous function. The point of discontinuity, the point of discontinuity at x equal to 0. Question number 9. F of x is equal to x divided by modulus of x if x less than 0, minus 1 if x greater than 0. When it is less than 0, we have to take this function. When x greater than 0, we have to take this number. And fx at x equal to 0, also this is the function. So at x equal to 0, f of x is minus 1. So f of here, let's so f of 0 will give minus 1. Left hand limit x tends to 0 minus f of x equal to limit x tends to 0 minus f of x when less than 0, left hand side of limit, so this will be the function x minus, let's modulus of x, modulus of x. Now modulus of x less than 0, it will give minus x. So x limit x tends to 0 minus x divided by minus x, cancelled, minus 1. Limit x tends to 0 minus minus 1, that is equal to minus 1. Now limit, right hand limit, x tends to 0 plus f of x is equal to limit, this is the function, greater than or equal to greater than 0, this is the function, limit x tends to 0 plus f of x, so that is here minus 1. So if we would put the value, it will give minus 1. So these three are equal. So it is a continuous function. Since it is a continuous function, there is no point of discontinuity. So these three are equal. Limit x tends to 0 minus f of x is equal to limit x tends to 0 plus f of x is equal to f of 0. So it is a continuous function. Or there is no point of discontinuity. No point of discontinuity. No point of discontinuity. This is question number 9. Question number 10. F of x is equal to x plus 1 if x greater than equal to 1, x square plus 1 if x less than 1. At, we will check the point of discontinuity at x equal to, since we have the less than equal to 1, less than equal to 1 and greater than equal to 1 and x less than 1. So we are going to check the point of discontinuity at x equal to 1. So first, at x equal to, which one is the function? This is the function, x equal to 1. So f of x is equal to x plus 1. Now f of 1, instead of x, place 1. So 1 plus 1, so it gives 2. Now left hand limit x tends to, because we are going for the 1, left of f of x equal to which function? X tends to 1 minus left of limit, so less than 1. So this is the function x square plus 1. Now instead of x, put it 1. So it will be 1 square plus 1, that is 1 plus 1, that is equal to 2. Now right hand limit x tends to 1 plus f of x is equal to limit x tends to 1 plus, which is the function, greater than 1. So x plus 1, that is x plus 1 equal to, instead of x, place it 1. So 1 plus 1 is equal to 2. 2, all are equal. So it is a continuous function. Limit x tends to 1 minus, means 11 limit is equal to limit x tends to 1 plus f of x is equal to f of 1. So it is a continuous function. It is continuous function. No point of discontinuity. No point of discontinuity. Discontinuity. No point of discontinuity. Question number 10. Question number 11. F of x is equal to x cube minus 3 if x less than equal to 2, x square plus 1 if x greater than 2. So we are going to check the point of discontinuity at x equal to 2. At x equal to 2. At x equal to 2. So at x equal to 2, which one is the function? This is the function. F of x is equal to x cube minus 3 implies, instead of x, f of 2, that is 2 cube minus 3. 2 cube, 2 2s are 4, 2 2s are 4, 2 2s are 4, 4 2s are 8, 8 minus 3, 8 minus 3, that gives 5. 8 minus 3, that is 5. Now left hand limit and right hand limit. Limit x tends to 2 minus f of x is equal to limit x tends to 2 minus which one's function? This one. Less than means this one. X cube minus 3. X cube minus 3 is equal to, instead of x put it 2. So 2 cube minus 3. 2 cube 8 minus 5, that is 8 minus 3, that is equal to 5. Right hand limit, limit x tends to 2 plus f of x is equal to limit x tends to 2 plus which one is the function? Greater than 2, this is the function. So that is x square plus 1. X square, instead of x place 2, so 2 square plus 1. 2 square is 4, 4 plus 1 is equal to 5. All these three are equal, so it is a continuous function. Left hand limit, limit x tends to 2 minus f of x is equal to limit x tends to 2 plus f of x is equal to f of 2. It is a continuous function. It is continuous function. So no point of discontinuity. No point of discontinuity. So there is no point of discontinuity. Question number 12. F of x is equal to x to the power 10 minus 1 if x less than equal to, if x less than equal to 1, x square if x greater than 1. This is the function. We have to check the point of discontinuity at x equal to 1. Why it is a 1? Here is when we have the value of x less than equal to 1 and greater than 1. Therefore, we have to check the point of discontinuity at x equal to 1. So at x equal to 1. So f of x at x equal to 1, which one is the function? Equal to 1. So this is the function x to the power 10 minus 1 over the f of 1. So instead of x place 1. So 1 to the power 10 minus 1. 1 to the power 10 is, that is 1. 1 to the power 10, that is 1 minus 1, that is equal to 0. Now left hand limit and the right hand limit. Left hand limit of x equal to 1, left hand limit of 1 and right hand limit of 1. So limit x tends to 1 minus, because this is the left hand limit represented by minus 1, so it represents the left, equal to limit x tends to 1 minus which f of x, which is the function, less than, so this is the function x to the power 10 minus 1. Instead of x place 1, so 1 to the power 10 minus 1, 1 to the power 10 is 1 minus 1, that is equal to 0. Now right hand limit, limit x tends to 1 plus f of x is equal to limit x tends to 1 plus which one is the function? X square. So instead of x, now place 1, so it is 1 square is equal to 1. Left hand limit and right hand limit is not equal. Limit x tends to 1 minus f of x is not equal to limit x tends to 1 plus f of x. So it is discontinuous. It is discontinuous. Discontinuous. The point of discontinuity, x equal to 1, x equal to 1 is the point of discontinuity, is the point of discontinuity. So this is the point of discontinuity. It is discontinuous at x equal to 1 because the left hand limit of 1 is not equal to the right hand limit of 1. Therefore it is a discontinuous function. Question number 13. Is the function defined by f of x equal to x plus 5 if x less than or equal to 1 and x minus 5 if x greater than 1 is a continuous function? Here we have to check it, is it continuous function? So the everything will remain the same. The process of solving the question to remain the same. Here before we have to find a point of discontinuity. Here we have to check it, is it continuous or not. Everything remain the same. So this is the first question. This is question number 13. First let's write the function. Question number 13. The given function is f of x equal to x plus 5 if x less than or equal to 1, x minus 5 if x greater than 1. We have to check the point of discontinuity at x equal to 1 because we have the value of we have the function at x greater than or equal to greater than 1 and x less than or equal to 1. Therefore we have to check the point of discontinuity, or the check the is the point continuous at x equal to 5, x equal to 1. So at x equal to 1, at x equal to 1, which one is the function? Equal to 1. So this is the function, f of x is equal to x plus 5. Now f of 1 is equal to, instead of x plus 1 plus 5, so it will give 6. Now right hand limit and the left hand limit x tends to 1 minus, so this is left hand limit. So limit x tends to 1 minus, which one is function? Less than, so this is the function x plus 5. So instead of x place 1 plus 5, it will give 6. Limit, now right hand limit x tends to 1 plus f of x is equal to limit x tends to 1 plus f of x, which is the function x greater than 1. Right hand limit means greater than 1, x minus 5. So x minus 5. Instead of x place 1 minus 5, it will give minus 4. These two are not equal. Right hand limit x tends to 1 minus f of x is not equal to limit x tends to 1 plus f of x. So it is a discontinuous function. It is not a continuous function. Is it continuous? The question is the function continuous? So it is not continuous function. Continuous function.